Hey everyone, and welcome. We all know solar power is this massive success story, right? But here's the thought. The tech that got us here, well, it might not be the same tech that takes us all the way. So today, we're going to dive into the incredible innovations that are totally redefining what a solar panel can even be.
I mean, just look at this number. We've already got 1.6 terawatts of solar power installed across the globe. That is a staggering achievement, and it's built almost entirely on one champion technology. But as we aim for a truly 100% renewable future, we've got to ask a pretty tough question.
Are the solar panels we use today really good enough for tomorrow? Is the technology that started this whole solar revolution actually capable of finishing it? To figure that out, we really need to get to know the material that powers something like 92% of all solar cells out there.
And that material, of course, is silicon. For decades, it's been the undisputed workhorse of the solar industry. I mean, it's a legend, but it's starting to bump up against its limits. Let's break down exactly why that is.
So with silicon, you've got this real tension. On the one hand, yeah, it's proven, it's durable, it gets the job done. But on the flip side, it's literally hitting a physical wall in terms of how much more efficient it can get. Plus, the supply chain is, well, it's heavily dependent on just one country. And then there's the growing waste problem. We're talking about a potential 1 million tons of scrap panels every year in Germany alone by 2030. All these challenges, they make one thing crystal clear. We have to innovate.
Okay, so how do we do that? Well, the first path forward is to take our current technology and just make it even better, to squeeze every last drop of power out of every single panel.
And we can start with an idea that is so simple, it's brilliant: bifacial panels. So instead of just capturing light from the front like a normal panel, these things use a transparent back to soak up all the sunlight that reflects off the ground. It's kind of like getting a free power-up, right?
And just how much of a power-up are we talking about? Well, get this. If you install these panels over a snowy surface, you could boost power generation by up to 25%. That's huge. Even over something boring like sand or cement, you're still looking at a solid 10 to 15% gain. That's an incredible leap in efficiency just from a simple design tweak.
But what if you could do more than just tweak? What if you could totally smash through silicon's physical limits? That's the mind-blowing idea behind tandem solar cells. Think of it like adding a turbocharger to an engine. You layer a new, more advanced material right on top of the silicon to capture parts of the light spectrum that silicon just can't see.
And just look at the results. Wow! Silicon's theoretical limit, the absolute most we thought we could ever get out of it, is 29.4%. But by pairing it with a material called perovskite, researchers just hit a new world record, 33.1%. I mean, they didn't just inch past the limit, they blew right past it. This opens up a whole new frontier for generating power.
But making silicon better is just one part of the story, right? The other, maybe even more exciting path involves creating totally new kinds of solar cells from some really revolutionary materials.
Okay, say hello to graphene. This stuff is basically a wonder material. It's a sheet of carbon that's only 1 atom thick. But get this, it's 200 times stronger than steel, it's incredibly lightweight, it's flexible, it's transparent, and it's an amazing conductor. All of these properties make it a near-perfect candidate for building the next generation of solar cells, cells that could look and feel completely different from anything we use today. And this is where the power of organic solar cells really shines. Because they're made from abundant, carbon-based materials, they could completely eliminate our need for those critical raw materials and break those tricky geopolitical dependencies. Plus, they're so lightweight and flexible, you can produce them like a film, which means you could literally install them almost anywhere you can imagine. Okay, but what about that waste problem we talked about at the beginning? True innovation isn't just about making better, more powerful panels. It's also about figuring out what happens at the end of their life. The real goal here is to build a truly circular system.
So you've probably heard this claim before, right? That clean energy just trades one problem, fossil fuels, for another, mountains of waste. And look, it's a serious concern, but it kind of misses a fundamental point about how these technologies are actually designed.
Because the reality is this. Unlike fossil fuels, which you burn and then they're gone forever, renewable technologies are designed from the very beginning for material recovery. Their parts aren't waste, they're valuable resources for building the next generation of clean infrastructure.
Just take a look at what's actually in a typical solar panel. About 95% of it is just common glass and aluminum. And we already have great existing technology to recycle both of those. We're not talking about exotic, toxic stuff here.
These are building blocks just waiting for a second life.
And for the more complex next-gen materials, well, we're developing really advanced recycling methods like dissolution. Basically, this process uses a special solvent to separate all the components at a molecular level. This lets us recover not just the plastics, but the full-length, high-quality fibers inside them. In essence, nothing is lost. The materials keep their value and are ready to be used again.
So when you put all of this together, what does it all mean? Well, it points to a future that isn't really about finding one single magic bullet solar panel. The future of solar is more like a toolkit. It's about supercharging the silicon we already have with these amazing tandem cells. It's about developing new, flexible organic films for all sorts of new applications. And it's about underpinning the whole thing with a circular economy that recovers and reuses every last valuable material. It's just a smarter, more resilient system all around.
So, with all these different tools in our toolkit, each one solving a different piece of the puzzle, the question really isn't if we can power our world with solar anymore. The real question we should be asking is, what kind of cleaner, more innovative world are we going to choose to build with them?